Awesome. So I understand that a lot of people here may have different levels of proficiencies in Linux. So this is a very intro to like Linux and the HPC server, just so that when everyone gets HPC access, they know how to kind of go in. So I know like Some and Waleed and Mike might and Tony might have more experience. So if it's dull, feel free to leave. I don't want to waste anyone's time. Um, I did post something on the lab journal, which is just something that you would want to reference. It's just a lot of comments and then me explaining some things. So, okay, I kind of wanted to go over like a couple things before the whole Linux stuff. So I have some tools on my computer that kind of make my life a lot easier. The first tool that I use is my editor, Sublime Text. I recommend that. It's easy. It's kind of a minimalist tool. It has text highlighting, so you can choose the uh, the language you're using, and it highlights it according to that language. And I find that really helpful. There's find and replace, and it's really easy. I find things like VS Code um, too too complex, or it's just too I don't know. I think it's just too much. And then I know a lot of people are used to typing in and coding in RStudio, but I think that's too specific, because when you get to writing like bash scripts for Linux, it doesn't really do the job, because RStudio is only for R. The second tool I have is something called CopyClip, which is for Linux. For Mac, it's a tool right here. I helped some people here get this, and all it records the history of your copy and paste, and you can set it to be longer than this list. But it's very helpful when you're moving around a terminal and you might execute a couple of commands, and you might not remember what you copied a while ago. So I use this all the time, and it saves me constantly. The third tool I use is actually my terminal. I don't use a default terminal for Mac. I use iTerm. iTerm like 1 or 2. I put the link here as well. And I don't know if this is for Windows, but the reason why I like this is because beyond being able to like change the background or whatever, you can double click on a word and that copies it. So in the regular terminal, you have to highlight then copy, but it's really simple to just copy and then paste. Okay. Okay. So when you open up your terminal, right? I don't know if how many people have ever kind of used Linux before to get onto servers, but usually when you want to remote connect, you use a command called SSH, which is some acronym for tunneling to a server. And the standard is to have SSH, your username on the server. So that's whatever your digital identity is for CHOP. Mine just happens to be Moyer EJ. And then you do add an IP address. And there's a whole protocol to get your IP address, and there's multiple different ways, as Michael and I have discovered, of doing that. Basically, when you get your digital identity, I'll work on putting together some sort of tutorial to how you should get the IP address. It has to do with basically requesting a compute node from CHOP server, and often you do that using VMware, and you connect through CHOP's first VPN, and then you can request a node there, and then you either get an email of your IP address, or you can just go on the virtual machine and type in like IP-6 address or something, and you get the IP address to log in. So for those not familiar with like Linux or how it's set up, you can set up something called aliases, which I'll get into later. And these are just shorter versions of code. So I set up an alias, SSHZ, for SSH to Zhou Lab. I set up something similar for Drexel, that's SSHD. I just, a little bit of a shorthand. Okay. So like I said, like Mike, Some, and Walid are probably more familiar with this than a lot of people, but I just want to go through some things and like my thought process to motivate what we might want to do. So, right. So we logged in, we're in Linux. This is Linux right here. You see some things are loading, and I'll go over that. And you see that you are, it's going to show up with your ID and then the server you're on. So I just want to see like where we are. So there's a nifty little command that is called read link. And read link is a command that takes in either a file or a directory, and it tells you basically the location. So we're in home, and this is my chop ID. So if I were to go to the home directory, I would notice that there are all of everyone's account is under there, and that's because in the server, all the file drives are connected. And so it's important that when you're navigating through the files, you kind of stay within your home directory. So this read link -f, that's to indicate that it's a file. And this dot is to indicate that that's your current directory. That's just something in Linux. And so I think that this is a pretty long way of typing that if you want to just have a quick way to kind of know where you are, kind of know where a file is. So I wanted to introduce a couple things. So I mentioned the term alias before, which I had SSHZ. And basically, we're appending it to the bashrc file. And I'll go over what a bashrc file is right now. But the bashrc file is basically a file that gets loaded for your gets loaded on login for your personal home directory. It's stored in your home directory. Actually, if I do ls-a, you can see that the file is stored right here. So a way to do this is to kind of write out the command and append it to the bashrc file. So these double arrows indicate that you're appending to a file. You can kind of think of it as pointing to a file. And then echo is just spitting out the string. So if I were to just execute this line right here, you'd see that I would just get this. And this is what, if I actually wanted to type into my bashrc file, I type that line at the bottom. But just because I want to do it all on the command line, I can just do this. It'll append it to bashrc, and then source bashrc is what reloads it so that I can use rf dot to show me where my home directory instead of read link -f dot. Okay. Echo is one useful command. It is used to basically print. It's kind of like a print equivalent in any other language. And I use it, it seems simple, but I use it a lot for a lot of other scripts I write. Okay, so anyone have any questions? Okay.
Sorry, I actually want to ask. So you just made an alias to like tell you what directory you're in? Is that what it is?
I made an alias that is readlink -f.
Yeah.
So it basically shortens readlink -f to rf.
Okay, and you could
I
you could do that same thing with like SSH, like you were showing in the beginning.
Yeah, I made SSH I made this like the equivalent for me, SSH, my username at an IP address. I made that just SSHZ. It just saves some keystrokes, but after you accumulate a bunch of them, it saves time.
Awesome. All right.
Yeah. Okay. So
I had a question and I posted it in the chat channel.
oh,
Take a look.
in the Slack?
I was also going to ask that. He's asking what's the difference between present working directory, like PWD, versus readlink -f.
Oh. They do the same thing. But pwd, that's only your directory. But you might see if I do ls to see like the files, it's kind of like list, and I do rf and then like repo, it tells me that directory. I can't do that with pwd. They're different tools. They have overlaps, but they do different things. Does that answer your question? I don't have chat open. You can just
Okay.
you can just yell it out. Yeah, but that was a good question because I wouldn't normally think to do that. Okay, so right, we listed all the files, LS's list, and then well, we asked the question, well, are these all of the files? And the answer is no. We have some hidden files, and in Bash, hidden file, any file that starts with a dot is hidden. And you might ask, okay, so who has permission to access these files? And we add the parameter L either behind or in front of the A. I don't think the order matters. And it gives you each file on the very right-hand side, and then it tells you some information on the left-hand side. So the leftmost column is permissions. I don't know this column. This column is who's created the file, and I don't know what this column is either, but this is either modified or the date it was created. What's important for the left-hand side, though, that's kind of the most important because that's what determines permissions, okay? So you can split this up. I think there's like 10 letters here. And the first one specifies the type of file. So you'll see that this is L for symlink. You might see D for directory, and then you might see a dash for just a regular file. And then there's 9 characters that follow. This is just a repeating R, WX, RWX, RWX, and these sets of 3 correspond to permissions for different groups of users. So the first group corresponds to permissions for the user, which is you, and the second group corresponds to group. So you can set groups. So I'm guessing that the RESL end users is the group that I belong to, or the group that has access to the file. That's my guess for this column. And then I'm pretty sure that this last triplet represents either all or others. I think it'd be all. And you might see that, you might guess that this means the R is read, the W is write, and the X is execute. I'm gonna make this bigger so you guys can see it. The X is execute. So when a permission is not granted, like you might think that, okay, so what if I only want to view a file, right? So then this command might look like this, and that's the only, and I would be the only one who's allowed to read, write, and execute. And there's a command called chmod that can change the permissions, but I don't really see that being needed, but it's just so that you know what it means if you ever accidentally type ls.la. Okay. I mentioned symlinks, right? And some important ones actually are on the HPC. Okay, that is not what I wanted to show. Some important ones are on the HPC kind of wiki. So if you go to this link right here, Wanding put some symlinks that are necessary. So he put a symlink to references, software, Zhou lab, Zhou_lab, and then he suggested you create a symlink for your working directory. So right here, we have references, software, Zhou lab, and then to my working directory. And you can use the RF function that we created earlier to actually see where, well, if I do that for Zhou lab, it'll just say where it is. But if you want to see where Zhou lab actually is located, I think you can do which, and then Zhou lab. And that's just not how it is. So maybe you actually have to do ls.la to see where it's pointing to. So okay, so references is pointing to this directory here. There's some other way. There's some other way to unpack it, but I'm not entirely sure what it is. I could have swore it was which. Okay, so we can go pick around and see where see what's in some of these files or folders. So references is what holds a lot of the data that you kind of want to use for reference. I mentioned to Michael, John, and Akil that when creating a matrix for the Know You CPG project, you're going to want to reference the Infinium array, because you're going to be making separate matrices for Epic and HM450 and then WGBS. So if we just keep going into Epic, it has the manifest file, which I put on the Dropbox, and it has some index files. .tbi is important for tbmate, which I'll go into at some point. It's a command tool to kind of manage bed files or bed-like file storage. Okay. So you can do cd and then the directory, and you'll move to that directory. And then if you do cd ... that means the previous directory. So we just keep cd ... and I could even do cd ... /.. and that'll take me back to directories. So we go to software, and this is a bunch of different software that we download from the internet onto the server. I've downloaded I think Valgrind. That's a C debugging tool. There's another one called Lab Tools, and I think the difference is that that's tools that we build, and so that's just the distinction there. So the difference between Zhou Lab and Zhou _lab is that Zhou Lab without the underscore is mountable. So for instance, I could open my file browser, and I could connect to a server, and I could connect to Zhou Lab, and I would have access to everything. So it's just asking me which one in CHOP would I want to get access to. And then I have access to everything inside of Zhou Lab. And this is good for file transfer. So if I go to Zhou Lab, right there, you'll see that the folders are exactly the same. And we can talk about the specifics about like what is a sample sheet and why we have the lab journal some other time. And then I think that a lot of the files in Zhou _lab is in projects, or at least that's what I use. And this is for where I store data mostly. So I have this folder, and then I have this file, and then I have this file. And there's way too many to actually show you what's in there. Is there a question?
I have a question.
Okay.
Could you repeat, you mentioned the ls-la, like, shows you who has access, right? What did you say all of the DRW stuff meant?
Yeah, so, okay, it's, so, okay, A and L are toggles. They don't have to be used together. So if you just want the permissions of the non-hidden files or the files without the dot, you just do it with just an L. So the permissions, it's 10 characters followed by a dot. The first character corresponds to the type of file. So you'll see that this one's a directory, right? This one's an L because it's a symlink. And any files would have just a dash. So if I did LA to show you the hidden files, you'll see that .vim, that's a file. So it's a directory. .emacs has a dash because it's a file. And then the next 9 correspond to permissions. And you can look at these as triplets, so that's why I put spaces between them. And it's basically the first triplet corresponds to the permissions you have. The second triplet corresponds to the permission a group has. So this is the group that corresponds to that file that I highlighted right here, our RSL and users. That's just a group that can be managed in Linux. I think if I do like groups, yeah, those are the groups that are on HPC. So this is the group, and then these are their permissions for a type of file. So the middle three correspond to the permissions that group has. So if you're within that group and you try to access that file, then you can access it. But for this one, notice how there's an R and an X, but there's no write. You can, anyone in that group who isn't the user can read and execute the file, but they can't write to the file. And then the last one is what everyone can do, I think, or others. It would make more sense if it was others. So if you want to keep a file hidden, you would just make all of these dashes. So you're the only one that could read, write, and execute the file. Does that make sense?
Yes, thank you.
Okay.
I have a question about the symlinks.
Okay.
So what essentially is it like kind of like a quick key? Like it's just you get to like a directory faster? Is that what's
Yeah,
going on?
it points to you'll notice the arrow. It's kind of like a pointer. It points to another directory, so that, right? Because if I wanted to go to references, I would have to go
all
to
the way.
this. Yeah, I would have to go
Yeah.
all the way here, and it's easier to have in your home directory. And you can
Okay.
reference your home directory by doing like if I wanted to go to references, I could do CD. I could be anywhere. I have to make this more explicit. I'll go right here. If I'm here, I'm very far away from my home directory. If I wanted to go to my home directory, I could do CD. But if I want to access a file on my home directory, I could do like this a tilde dash, and now I'm in my home directory. So if I hit tab twice, it'll show me all of what's in my home directory. The tilde basically takes you home. And then I could go to references, and then I'll have all of them in the references that was normally accessible when I was in my home directory like I was here. And you can see the tilde is right there to indicate the home directory, because I'm the tilde that I'm accessing here, or where I am right here, is the tilde that's right here. So tildes take you home. Okay, so I moved to another random location, and this is where I keep some of my data, and this is raw data. And oh, I put a note here. So notice how I'm using full paths. This is important because this file that I'm using on the right-hand side of my screen in Sublime Text isn't actually stored on HPC. It's stored locally in some like a projects folder, lab journal, mine, tutorials, and that's where you find it on GitHub. That's where I posted it on GitHub. And the fact that it's stored locally means that this is like completely separate. So you want to always log full path names. It gets annoying. It gets kind of cluttering. But if you ever send code to someone else, they're going to want to know where the file is located without having to assume what directory you were in. Okay. So one cool tool to view files is called less, right? So if I wanted to view this CSV file, I could do LESS, and that would show me the contents of the file. Now, Wanding implemented an alias that's just LES, and that alias is just this with a small s, which just toggles off text wrapping. So you'll see that you can just go from like left to right, where when you did this one, it was wrapping around the screen, which is so it's easier to look at. So if you do LES, where is it? LES, yeah, and then the file, then it's just easier to look around. So I'm moving around with my arrow keys up, down. You can use Z to page down and W to page up, and then you hit Q to quit. Okay, to edit the file, you have to click I. Am I doing that right? Or I'm thinking of Vim, aren't I? I am. Okay, so viewing, right? I hit Q, quit. Okay. And the question is, so how might we edit this file? VI is for a text editor in Linux called Vim. You hit VI, and You can move up and down. In Vim, there's different modes. So right now we're in command mode. You can see that the command mode is specified by the colon. And so I hit colon, and then I hit I hit I to go into insert mode, and then I go hit escape to get out of insert mode. And if I want to exit the file, I do Q, enter. There's just a lot of different files there's a lot of different commands in Vim. I think if I do help, oh, that's bad. Do help, it'll tell you all of the commands you can do. Like you can delete an entire line. You can delete an entire line by just hitting double tapping D. You can undo by hitting U. It's very useful. You can do replacement in Vim by doing backslash. I think the command the regular expression that you want to search for, and then what you want to replace it with. So I could replace all of the 0.7s with 0.8. Hit enter, and it did not replace them. That's interesting. 0.7 replace with 0.8. End it with that. Hit enter. Maybe.
I think you might need like a % sign before it.
Before what I'm replacing with?
Yeah.
Okay. Like that?
I think you need at the start of the before the 0.7. Try putting it like before the first slash.
I think it's weird because I'm dealing with numbers, but if I want to replace all the CGs to CHs, CG, CH, just not how I do it. Oh, actually, okay, that's fine. So apparently I don't know how to do it. That's okay. Oh, and you'll notice that I made a change in the file. I don't want to save the change to the file, and it's not letting me quit. So what I have to do is I have to do colon, Q, exclamation point to make sure that I quit, and I do it without saving the file. Yeah, I rarely ever replace. I kind of just thought that would work like that, but it doesn't. Okay, so you might want to at some point rename files, right? So we could rename this. So there is no rename function. There is a move function. So you move a function. You move a file. You effectively move a file, but you change its name and keep it in the same directory. So I could make this csv.1, and it changes it to .csv1, and I could rename it back by just doing the opposite in the opposite direction. Now we have the regular file. You can copy the file by doing cp1, and now there is the original file and the copy, and then I can use remove to remove the file. So rm is remove, rf is a flag that means yes, I want to remove it. So if I didn't do that and I just did rm, it would ask me if I wanted to remove it. Yes. And you can imagine if you're doing it for a lot of files, that would get annoying. And then there's another toggle for RF for RM, that's R, which means recursive. So if you're trying to delete a directory, it's going to delete everything in that directory. Okay. Some more options. So if we want to know the number of lines, this is often helpful for a file, right? We want to know how many lines are in here. There are 388,000 lines, right? So that's a big file. And if we examine this file closer, you may have noticed that on each line, there is the probe, and then there are corresponding beta values for given cell types. So we have monocytes, B cells, CD4 cells, NK cells, and I think I don't know how many there are, but the list is all in the header. And so CSVs are particularly ugly. I don't like them. So we can actually do some magic with this. So I don't like CVs. Just as an exercise, let's make it a TSV. So a CSV is a comma separated value file, and a TSV is a tab separated value file. So there's this command called sed, which forms a replacement. And this is kind of the syntax I was trying to do in Vim. So that's kind of why I got it. That's where I got the inspiration. Basically, I'm pretty sure the S here is required. You can always do the command you want to execute and then dash help, and it'll tell you the toggles, and that's kind of how I navigate. Okay, so S dash, okay, this dash S is for a toggle, not for the expression here. Whenever I use sed, I always include an S before this, and basically when you're creating these, you have 3 dashes, 3 forward slashes. What's in between the first and the second one is what you want to replace. So we want to replace a comma, and then the in between the second and third is what you want to replace it with. So it's a tab, so that's a backward slash and then a T, indicate tab. And so without the G, it would mean that you'd replace the first instance, but we want to do a global replacement. So that's why we put a G. So we're just gonna replace this and hit enter, and that's bad because we have to use something known as a pipe. And this pipe is identified by the horizontal bar. And this is where we get into some things in Linux called standard out, standard in, and standard error. I hardly ever use standard error. But basically, what you saw on the screen, because it has nowhere else to, it's not suppressed and it has nowhere else to go. You can kind of think of it like that. It's printed to the screen, but we can direct the output from the screen to another function. This is pretty powerful. I could direct the standard output. I could direct the output of this file to the input, to take it in as standard input to less. Normally when we call less up here, either LES for non-text wrapping or LESS for text wrapping, we had to have the command and then the file name. But here, what we can do is we can just pipe it to less, and it'll know to recognize this file. So if we do this one, you'll notice that all the commas are replaced with tabs, and right, all commas are replaced with tabs, and it's not exploding the screen. If we want to exit, hit Q. And I asked, okay, what if we only want the first column? So we only want the CPG locations, or the, sorry, CPG probes. Then what we can do is we can use this command called awk, AWK. So notice how instead of piping it to first less, we're piping it to AWK and then less. So the output of sed will go as input to awk, and then the output of awk will go as an input to less, and that'll be what we can scroll through. So AWK is really interesting. The command's AWK, and what you want to execute kind of goes in between quotes, and then the file that you want to edit or manipulate goes on the end. But you could always do like less, or you do cat, which is okay. Cat is a way of just printing out the contents of a file, and you can use it to concatenate files. So if I wanted to just cat this file, pipe it to less, it would look exactly as if I just used less. That's because it's sending the output of cat, which is just the file, to the input of less, which is just the same thing as if I just used less to begin with. So if I did cat file, piped it to awk, and then the procedure would be to pipe both of these to less. So these two ways of writing this is equivalent. Basically, it depends on whether or not you have input from another function. So how you design the what's in between these quotes is basically, I like to think of the awk script having three parts. You have the beginning, the body, and then the end. The beginning is what happens before. Okay, let me step back. Basically, what awk does is it goes line by line on the file, and performs some sort of like it performs code on each line of the file. And usually this is useful if you want to, access a specific column of a file. If you want to look at column in a specific, you want to look at data in a specific column. So beginning is what executes before you ever seek through the file, before you ever go through the file. What's in between beginning and end is what you do on each line, and end is what happens when you're finished with a file. So maybe you're taking column averages and you want to print out you're taking column averages of a file and you want to print out the the averages for each column, right? So beginning might have some like variable initialization. The middle will have like addition to an array for each column, and then end is what is when you'll actually print everything, and you'll print the sum divided by the count for each column. I've done that before, and that's the structure on how you use it in awk. But because we just want to print out the contents of a single column, we only need the middle part, so we don't need beginning or end. And the code in here goes pretty similarly. You just do print, and then $ is a flag. It indicates, it lets awk know what column you're calling. So we're calling column 1. If you want to call the entire line, it would be just 0. And you can actually use variable. So if I had some variable that was looking at like mins and maxes, and I want to record where those mins and maxes were, and I stored them in a variable n, I could just do $n, and I could access that nth column. And I love using this tool for that very reason. So if we just want the first column, we pipe our results from sed, which convert the commas to tabs globally because the G. Pipe it to sed to just grab the first column, and you'll see here we just have the CPG. We just have the CPG probes, and we can hit Q to quit less. Okay. Any questions? Okay. So this body statement that's in between like an imaginary beginning and then an imaginary end that we just removed because we don't need it. You can precede this with logical expressions. I think they're called I think they're actually like a relational expression that evaluates the true or false. And so if we don't want the first couple rows, we don't want the first 2 rows, because as you remember right here, these first 2 rows are blanks. So this is kind of ugly. So if we're like sending this to, if we're loading this in R, we don't want to load any white space. Right, that's a good example. What we can do is we can use this variable that awk has, which is nr, which basically stands for the line it's currently on, or the row number. You could think of it like that. So we only want to print when we're at row number, where our row number is above 2. So you can imagine that this is row number 1, this is row number 2, and this is row number 3. So we'll start printing when we're right here, and it'll print for the entire file. So simply adding that will get us what we want. It'll get rid of the white space. Okay. And then we could effectively grab any column using that method. Like I said before, a variable or another number. This is 11. We want to grab the 11th row. You'll see that this is for heptosite, and here are all the beta values that were stored in that file. Okay. And so I mentioned there's like one way of doing this, but in programming there's so many different ways of doing this. So you might not want to assume that the only white space you see in the file is within the first 2 rows. So you're like, okay, well, I only want to print so we're doing an if statement in awk. Right, here's an if statement. So if some conditional wrapped in parentheses, if the 11th column does not equal blank space, print the 11th column. And this ensures that any white space within the 11th column will not be printed. And then this is the added fact of also including the name of that column. So we have heptosite here. Okay. And there's more solutions to this. So if we go back to the first column example, we can use a command called cut. So cut, the beauty with cut is if you have any sort of delimited file, like a CSV is a delimited file because it's delimited by commas. A TSV is a delimited file because it's delimited by tabs. You can send it to cut, and then you use the -F to kind of indicate what columns you want to cut out of the file. And when I say cut out, I mean return. So if we do -F then 1, and we view this one, it'll give us the first column with the white space. But if we want to do, I don't know, the first 5 columns, 1 to 5, 1, 2, 3, 4, 5, that gives us the first 5 columns. Because of spacing, these might look like, I know in Excel you might be used to like things being lined up like perfectly, but because it's just with tabs, if a long word is present, then it kind of shifts everything over. So these are still in line with these columns. And so you might want to just do, I don't know, the fifth to the end, right? And you get that, and you get the 5th one to the end. Pretty cool. And so we might say, okay, so the first couple of rows are still annoying. How can we get rid of the white space without using awk? Well, we can just grab the first column and pipe it to another tool named tail. And tail would normally grab the end of a file. So this is the bottom of the file. This is the last, I don't know, 10 or so lines. And what you can do is you can give it an argument, -n, and having -n plus the number corresponds to, it's in the notes that it does this, and that's how I know it does it when I do tail --help. That's how you kind of view, it's kind of standard for all tools in Linux. Normally it prints the last 10 lines. But if you do -n plus num, it outputs the last num lines, right? So if I do n plus 3, it'll print out everything starting from the 3rd line. And so I could change this number to 20, -20, and it'll print the last 20 lines. Okay. And then we can also use head, right, to do something similar. We print the first 10 lines. And that's what I wanted to get into today. I have like notes here to go into tbmate, which is probably what would help out a lot of people. If we don't have any questions, I can go into that because I think that people who would be using would get HPC access would effectively use tbmate, because that's kind of how we manage all of our files. That is how we manage all of our genomic data, like all the methylation data. And I'm kind of moving all of, I'm also encoded RNA-seq data, and I showed Michael how to do that too. But do we have any questions for like the commands I talked about? Any kind of applications or? Is this helpful, or is this too low level? Am I? I'd like some feedback.
It was helpful.
No, you're good.
Okay.
Yeah, it's helpful.
Yeah, thanks,
Okay.
Ethan. I think you're doing a good job. It's
Yeah.
really helpful.
Have you used these tools before, Waleed?
Some of them, but like I mainly work in R, but it's been a while since I coded a bash script.
You should use awk. You should use awk. Awk is very powerful.
I used it a little bit, but not too much.
Okay. So I have a folder here, we have some time, of TBK files, right? And these TBK files are binary files that you can create using tbmate, which is a package that, well, not a package, it's software that Wanding wrote. And this is used for packing files, so creating the TBK files, for viewing them. And he added like a bundle function, which is just to, I guess, kind of wrap them together. And so I think you guys will just be concerned with its usage. So I type tbmate and it doesn't stall, it prints the help, which is what we need. And so what you'll be concerned with is tbmate view, and that it prints out the usage, which is just some things that you'll need to know. Not all of them. So normally tbmate, if I do tbmate tab, we can view the contents of a file by doing tbmate view, a file, pipe it to less, and it'll show me the contents of the file. And really the contents of the file is what's on the right side, the rightmost column. But you may have noticed that all of these TBK files are in this folder where we have also a TBI and a .gz file, and these correspond to the index. So actually what's interesting with tbmate is that it stores in the TBK files, it stores the data here, but it stores the index in the .tbi file, the index.gz.tbi and the index.tbi file, the index.gz file. So it allows for faster random memory access or something like that. I know Wu Bing made his own version in Python, so he probably understands a lot better than I do. So if we want to view more than one file, you can just use dot. Remember, dot means everything in our current directory, or it means a current directory. So we just do that, and it gives us all the files, and it's all indexed with the same index file. So we can see the beta values for all the files in the directory. We might ask, okay, so what files are they? You may have noticed when I did tbmate view, there was I noticed one thing was .c, which displays the columns. Do that one. Type it to less. Right, we have seek name. 1 and 2 are there ambiguous. These are used for when we have genomic indices, where we have chromosome number, the start position of the chromosome, and the end position of the chromosome. And then after these first 3 columns, there's the sample name. Yeah, and you can do other cool things, like you can add another parameter, which is -g, which means genomic coordinate. We can't do that because we're not in genome coordinates right now. So I have some time. Another question you might ask, okay, so like this really isn't that helpful, right? This really isn't that helpful because it's not in a genomic reference. It's in a I don't know. It's in an array. I don't know whether it's epic or I don't know what it was encoded with. If I do tbmate header, shows you the information about when it was packed. So the header is important because it tells you the index file, and right, we know that this is epic. Okay, the epic Infinium array platform. So we want to find an index file that converts from epic to like a reference, like HD19. So we can just do -i to change the index, and then we can grab the index file from this file location. So it's an epic. Okay, I did that wrong. Less, there we go. I can see the files. And we'll see epic to HD19, unzip there. We'll want this entire file, put it there. And what's cool, we can view it, and this is just a way to map the probes, which are in this column, to the genomic coordinates here. We do this, tbmate view, less, and it shows us, pretty cool, right? It shows us all of the values from those TBK files with corresponding to the genomic location according to HD19. And now, if we want to explore more things about tbmate view, right, we might see there's a -g, right? -g, which means region. Okay, so we can select a region. We might just want to look at the first chromosome. So we do chromosome 1. I think that's it. Yeah, first chromosome. And then just make sure that I'm not imagining something. We can do chromosome 4. Chromosome 4. It's a very easy way to manage files. Often we might use another flag, which is I don't know actually. There's one thing to like turn negative values into NAs, or use NA for that's -d. -d. So instead of the negative values, you'll get NAs, and this is better for when you're exporting to R, because you just because then I think when it loads into R, when you do like read TSV or something, you like read TSV, it automatically converts it to ORS, NAN, or whatever null data type. And if we want to export this as the file, you just use this. You do a dot bed. I know that's I guess it's an okay name. And you just pipe it. I'm sorry. You direct the output to a file, and then we can view the contents of the file. And it's that same. It's that same thing that I viewed in less. And I can remove. I can remove that. Yeah. So, when we have genomic data, then we can start using other tools like bed tools, and those are helpful for finding intersections between files. So I'll just give you a little primer to what we might do next time if we decide to meet. Like bed tools intersect, I've used this before. It takes two files and it finds the intersection between the two, and then there's a whole slur of parameters you might use to find intersections and format like output. But yeah, that's a lot. Cool. All right. Any questions? I guess that's it for me. I didn't really have that. I didn't have tbmate scripted or anything. They're all quiet. Oh man.
So when you use the SED function, is that required when you're doing awk?
Sed?
Sed, yeah.
No. Sed is just a tool, and I only use that because I wanted to convert from a CSV to a TSV.
Okay.
I wanted to convert the commas to tabs.
Okay, so as for awk, like how would you pump in a file without having to change it with from file or from commas to tabs?
So if we have this file right here, and we just want to print out the first one, the first whatever column, you can just do awk in the file to less like that.
Okay.
So instead of piping it, you just provide it as an argument. And Yang was so kind to format this as a TSV. So that's why. Yeah, but good question. These are just tools I use. And also, you might have noticed that I quickly just used the screen. And screen creates, so like right now I'm in like one window, but screen, if I go into a screen session, I have 8 windows, and I could use FN and like F12 and F11 to like move between all of them. So I can store different sessions. There's a lot of cool things. If I want to exit, I do Control A, Control D, and I'm back where we started here. John, Akil, anything?
I'm just trying. I mean, I'm gonna rewatch this part again to understand awk more because I feel like we might be able to use it for CPG. So
Yeah, that's kind of what I was hoping you do.
Yeah, so I think so I'm just gonna rewatch it a couple times to get a better understanding of it. I think.
Any questions?
I got like
Sorry?
I got like the main idea of it down though.
Okay. Yeah, Michael?
I was just saying, I think I have the idea for when we meet.
Okay, cool.
How to use these words.
So it was helpful?
Yeah, I think it was really helpful because there was a lot of holes in my knowledge, at least for me.
Yeah.
Like if it's kind of like ironed it out more.
Yeah. Would you guys like to do this again sometime?
Yeah.
Yes.
Sounds good.
I'd say yes.
Certainly.
For sure.
We can explore different topics, and if you have like things you've seen that are holes in your knowledge that you'd like want me to like explain or kind of explain to the best of my ability.
Sounds
like,
good.
let me know.
We can maybe have some other people lead their own topics too, so like everyone's involved.
Yeah, sure.
I'm so glad you just said that it's Control D to quit, because I was trying to do that before, but I was using Command D and I was wondering why it wasn't working.
Yeah.
So thank you.
Yeah. Yeah. If you only could see my keyboard, but cool. Yeah. I said I was going to post this to my YouTube channel, and I'll like send the link to the recording in case any of you want to rewatch it. If you have any questions, just let me know. I've been using these tools for, I don't know, a long time. Well, not like a long time. Not as long as Wanding has, or some of the other, or probably like some of the other grad students. But I've been using it for pretty consistently for the past like 6 months. So you get used to it. It's just practice. You just gotta fail a lot. I'm serious. Cool. Well, sure.
I have a general question. You accessed the lab files. Was that just putting in, like, how do I do that?
Like, do you mean like SSHing?
Yes.
Yeah. So when you get your digital, that's why Wanding was asking you whether you have your digital identity, because your digital identity will be the username, and then we'll be able to like use different tools on your computer to get you your IP address.
Okay, like I have my digital identity.
Oh, you do?
So like I do. So like you logged into your, I thought you're using a Chop email to log in.
I used my user, so I did like. Sorry if I hear Slack going off.
Like, this is where it gets complicated.
Yeah. So I'm gonna like talk about something. If you want to like get a head start, I would download something called VMware Horizon Client. That's kind of what you use.
Is that how you guys interface with Chop?
Yeah, that's how you
Okay.
request for a computer node, a compute node. You need VM Horizon Client, and you also need Cisco AnyConnect. Those are two tools you'll need. So if you want to like figure out,
But wouldn't wouldn't VM bypass you needing Cisco Connect though?
no, you need you need AnyConnect to get connect to the VM.
Really? Because we use the same thing. I use the same thing for my hospital work, and I just do straight VM for my. I put it for VM. I put in the server address and it gives me direct access.
Oh, maybe. Well, you're gonna need AnyConnect anyway to use this to SSH.
Okay, sounds good.
Yeah. Okay. You might be right about that. But I use I just like whenever I start working and I need an IP address, I just like open up both of them.
Okay, yeah. No, because how VM works for us is it gives me a VPN connection to the server first, and then that gives me direct access to the site. Then after that from VM.
Yeah.
So, I mean, I'll double check it though.
Okay, that's okay. Cool. Yeah. So yeah, basically you log in and then I can show this so it's there. Okay, you won't see it good. You log in right here, and then to request the compute node, you double click on RHEL HPC2, and then you have to go into that virtual machine, and then type in like, I think it's like IP, was it IP-6 address or something, or it's IP-6 address in VMware, and that's how you get the IP address. If it's neither one of these, then just Google.
For me, it was neither one, so I had to do just IP add R, and that's how I got mine.
It was IP-R.
Add R. I don't think it was even dash. I'm pretty sure I just did add R. I just removed it. Yeah.
Nice. So there's it might depend on like what node you get. I know that this one worked for me, and then I saw this on Google, and then Mike did this. So yeah, just keep failing till you don't.
Well, I said add R. Sorry, like ADDR.
Oh.
Sorry for the confusion. Yeah.
Oh, without the 6. That makes more sense. Yeah. Cool. So I'll stay for questions, but we're done here. Hopefully you all got something out of this. We'll I'll figure out what we can do next week. We can go over topics if there's like a request. I could show you more examples with awk. Like for instance, here's what I'm using awk for. Like I'm using awk to classify. This is a really long script. I'm using awk to classify these branch IDs, right? So down here I have each branch ID with regular expressions that I'm looking for in a file, and I'm kind of just creating a giant branching statement and then doing some optimization at the end, and I print out the branch ID for each sample. But I've used awk for a lot of things, so yeah, I could go over some examples. But cool. Thank you for participating. I'll be around for questions if there are any. Otherwise, I hope you guys have a good night.
Thanks, Ethan. See ya.
Thanks,
You got
Ethan.
it. Go see ya.
Thanks, Ethan.
Thank you.
Thank you.
Mhm.